This video demonstrates how I engineered and installed my own e-parking brake on the ProMstr Ram. Our vehicle uses cable emergency brake over calipers, so we use a cable e-brake concept. There are two reasons for installing the e-brake. The first reason has to do with the emergency brake cable I show in this picture. The axle cables are at the back of the vehicle, and there's a metal rod that runs up towards the front of the vehicle where the bell crank is, which connects to the cable. This long rod interferes with underfloor tank installation, and it has to be removed. The second reason is more complicated. We wanted to lower the seats. The seats are too high. The stock seats make you feel like you're driving a bus. We want to drop the seats 2 or 3 inches. Well, you can't add a swivel and drop the seats at the same time, so we had to build our own swivel concept. Once you have a swivel concept going on, the emergency brake, which was mounted on the seat risers, now has to be mounted someplace else. As you can see, we relocated the emergency brake handle down in the footwell, but that was too limiting. The cable and the handbrake assembly were shaped such that you couldn't get a good fit, and we didn't want to cut up the plastic insert that goes in the footwell, so we decided on the e-brake instead. This is our final installed product, minus the splash cover to keep water and debris from getting into the mechanism. The unit itself is a sealed unit, and we'll discuss more about the unit in a moment. As you can see in the picture, the linear actuator is about 7 inches long. It generates 225 pounds of force and has a 2-inch stroke. It also runs on 12 volts. It has internal limit switches, so you don't have to worry about limit switches. It also has an internal ratchet. In case it gets overloaded, it will ratchet and not burn itself up. This unit was purchased on Amazon for about $50 and took 2 days to receive in the mail. To keep this project as simple as possible, we relocated the factory bell crank from the forward section back to the rear crossmember right in front of the brake cables. The holes were already there with threads ready to just move it. All you had to do is move it. Then we modified the rod using both ends and shortened it down to about 7.5 inches in total length. This retains the factory cable adjustment capability. Next, we measured the effect of the emergency brake handle, the factory emergency brake handle, on the bell crank, and found that the cable side going to the emergency brake arm moved 1.5 inches with full brakes applied, and the rod going back to the rear axle moved 3/8 of an inch. So it's a simple matter of using ratios to figure out that we could change the hole on the bell crank, and this would allow 2 inches to move the bell crank hole 3/8 of an inch, and that ended up being 1 inch from the pivot point of the bell crank, as shown in this picture where the bolt nut protrude. So then we screwed the modified bell crank to a workbench and moved it 2 inches and watched at the rod end move 3/8 of an inch, which confirmed our calculations. Next, we welded up this actuator holder consisting of 2 pieces of angle iron and also a piece of plate steel. This assembly was bolted with pop nuts into the crossmember of the van, adjacent to the bell crank assembly. Here's another view looking towards the rear of the van, showing the assembly. And next we made a link out of 2 pieces of plate steel. The holes are 1.5 inches apart. We used oysters and nuts as spacers, and we now have an assembled unit. The power head is finished. All it needs is the splash protection cover. Here you can see the blue limit switch, which there's a little pin on the end of it. When the brake is off, it pushes this pin in, and this tells the body control module that the emergency brake is off. When the emergency brake is off, it turns off the brake light on the dash panel. Here you can see my wiring diagram for the parking brake electrical diagram. At the top we have the e-brake motor. This provided 12 volts DC down through this double pole double throw switch, which has an on-off-on position setting. Down here we have a safety relay. The relay energizes anytime the ignition key is on. And what that does, it opens up the normally connected contacts of that relay, and it prevents the battery voltage from getting to the brake switch. If the key is turned off, then the battery voltage can get to the brake switch. This limit switch is mechanically connected to the e-brake motor, so when the motor drives the brake to the off position, this limit switch provides a ground to the body control module and turns off the dash light saying emergency brake is on. When we place this switch in the brake off position, the contacts actually go to the opposite side. So we have ground going through the bottom pair of switch contacts up through the wire to the plus side of the e-brake motor, and we have the top side of the switch receiving the fuse, 6 amp fuse, 12 volts, and that goes up to the negative side of the e-brake motor, and that drives the motor backwards, which turns off the brake. This sends a ground signal to the body control module, signifying that the parking brake has been turned off. So now let's turn the parking brake on. You notice that the battery voltage comes down through the safety relay, normally called contacts, goes up to the contacts, runs through the contacts, goes up to the positive side of the brake motor. And the ground side, as you can see, goes up to the top contacts, goes up through the next wire to the negative side of the e-brake motor, and that runs the e-brake motor on until it homes. This also turns off the limit switch. So there you have it. The parking brake cannot be activated while you're driving. It can only be activated when you turn the ignition key off to park. If you turn the key on to start the engine and realize the brake's on, you can still turn the brake off even though the ignition key is on. ProMstr forums noted that these brake cables tend to freeze up in the wintertime. The cable slopes downhill towards the wheels so that water blows in the front of the cable right here and freezes the cable solid during the night. And then they can't release their brakes the next day. So we took a piece of pipe insulation, cut a slit in the top, slid the slit over the existing cables and pushed it into this little bracket that holds the cable assembly. Then we just simply cable tied that piece in place so that it keeps pressure against the cables, and any water that hits this area should run down the pipe insulation and not flow back into the cable itself. This concludes my do-it-yourself e-parking brake.